In this video, we are going to create a new list that contains all the prime numbers from the given list that are less than the threshold given. Hello, I'm Jagan from growwithdata. I am posting this video to share my knowledge in Python language with you. If this assists you in your interview preparation anyways, I'll be happy. I have created a playlist Python interview questions 51 to 100 and I'll be tagging this video to the playlist. If you want to copy the code used in this video, you can go to the YouTube channel growwithdata and you have the videos and playlist. We have the Python interview questions 51 to 100 where I'm going to tag this. You have the Tamil version of it, Python interview questions 51 to 100. You can try that too. If you go to that video, you have all the videos related to that series. And in the description part, there is a GitHub link. And we click on the link, it will take you to the code we discuss in this video. And if you want to join the WhatsApp channel, there is a link here. You can join growwithdata WhatsApp channel using this link. Great. Now let's go into the code. Before that, let's see the data. So we are given an array and a threshold number. So what they are asking us to do is we have to find the prime numbers from this list and make sure that number is less than this threshold. So the first question here is, what is a prime number? So prime number is a natural number that is greater than 1 and has no positive divisor other than 1 and itself. That means if you have a prime number, that number is only divisible by 1 and itself. If you see 2, 3, this number can be divisible by 2 and 3 itself. There is no other number other than 1 can divide 2 and 3. And if you see 7, there is no other number which can divide 7 other than 1 and itself. Same like 11 and 13. So these are the numbers which are prime numbers. So in this list, what are all the prime numbers? So we have 2, 3, 7, 11 and 13. So if you see 13, which is greater than the num, so we have to ignore that. So the expected output is going to be 2, 3, 7 and 11. So how will I get that? So I have to get every number and then I have to go in sequence from 2 till that number. I have to see if that is divisible by the sequence. For example, if I say 8, right? So 8, I have to look for 2, 3, 4, 5, 6 and 7. I have to see if this sequence can be, the 8 can be divisible by any of these numbers. If that happens, then 8 is not a prime number. So 2, yes. 4, yes. So from this, we get 2 and 4, which can divide 8. So 8 is not a prime number. If you see 13, so for 13, when you start with 2 till 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So of this, which are the numbers which can divide 13 without a remainder? None of them, right? So 13 is a prime number. But the thing is, you don't have to go from 2 till the end. We can just at least go with the half. Like half of 13 is going to be 6 and of something, right? So you try till 6. So maximum is 6 goes with 2 point something, right? So 7 is going to be 1 point something. So we can go till here and check if this is divisible. More than 6 or 7, there's no point of doing it. But other than that, if you find the square root of this 13, so how will you find a square root of a number? You say 13 into 0 0.5, exponent 0 0.5. So it's 3.6. So when you go with the integer part, get only the whole number 3, right? So when you see the numbers which can be divisible by the sequence, you can go only till 2 and 3. You don't have to go with other numbers. If this number can't divide 13, the other numbers can't. So if you see 8, right? So the square root of 8 is 8 exponent 0.5. So it's 2. So you can check only till 2. If 2 can't divide 8, then none of the other numbers can't. So 2 can divide 8. So this is a non-prime number. So if even 10, you can look the same. 10 is going to be 3, right? So you can check with 2 and 3. If none of these numbers divide 10, then 10 is a prime number. But 2 can divide. So 10 is not a prime number. So we have to use this formula rather than going with the full sequence. Okay. So how to do that? Let me create a function for this input. The grow with data, the input list and the num. I have the variable result, and then I'm looping in all the elements from the input list. I in input list. So main thing is it should be greater than 1, right? So if I is less than 2, or you can say less than or equal to 1, or I is greater than or equal to the threshold, then we just say ignore this and continue with the process. If it's a valid one, it's between 2 and the threshold, then just have a flag true, and then for j in range, we have to find the range. So how far we can go, right? So for range from 2 till the integer of I square root plus 1, because when you go with range 2 to 5, it goes 2, 3 and 4. You don't consider 5. So we just add 1 to make sure we go till the last number. If the I can divide by j without any remainder, then we set the flag as false. Now we break. So if there is one number which can divide, then there's no point of going further. So if the check flag is still true, that means there's no other number which divide the input by element, then we say the result dot append that element. Okay. So what we did, we take the input variable, read line by line, one by one, and check if it is less than or equal to 1 or greater than the threshold. If so, you ignore and continue the loop. And then you get the range from 2 till the square root of that number. Plus 1 is for the range problem, right? You don't take the last number, so it's plus 1. If this element, one of the element, is divisible by the sequence 2 till the number, right? That sequence without any remainder, then you set the flag as false, and then you break the loop. So if the check is still true, right? The check is still true and nothing happens with the if condition, then you append the result. So in that way, we are going to see all the prime numbers. We get an error, j equal to 0. Oh, here it's j. So we have to return the result. You are return the result. So we get 2, 3, 7, and 11. If you want to test with more test cases, then you can go here. Everything looks fine. If this sequence, none of them are prime numbers. So everything have a, oh, sorry, the threshold is 1. So 2 and 3 is greater than the threshold. So you get blank. For here, 2 and 3 is the only prime number which is less than 5. So we get this. And here we go till 67 because the threshold is still 100. Great. Now the code looks fine. But when you see this looping part, right? So we are doing it repeatedly. So the best coding is we can break down this loop and continue part of it, right? So we don't have to do this. We can do a better coding part. So what I'm going to do is to eliminate this break and check flag, I'm going to create a function here. So diff is prime is a function within the function is prime. I'm taking that value I, okay, and then I'm doing the if condition here. I'm doing the if condition here. If that number is less than or equal to 1 or greater than threshold, there's no point of doing other things to return false. You can break the loop and you directly go. If not, you say for I in, let's copy it, range here, say j, sorry, last time the same mistake. For j in range here, we check if it's divisible by j. If it's divisible, then there is no point, return false. Else, you return true. So you don't need to have the check and the break part of it, right? So I just go with the input variable and I check if is prime of I. If this is going to return true, then you append to the result. If not, the false will return, which is not going to append. So now if I run this, it works fine. So rather than doing all the break and looping part, I simply return the false if it breaks here, or I return true. This is much easier. I can further reduce this code complexity. How? First thing is I can make this as a list comprehension. How will I do it? We have done in our previous video. We take this and put directly into the loop, and then I check if is prime, then you loop it. No need to go for append, and then directly result, right? So I completely ignore the 3 lines of code into a line list comprehension. And then I can work on this condition also. I can just take this and I'll put it here and I'll say, and instead of less than or equal to 1, we are flagging it. We say if it's only greater than 1, then you call the, you append the function. Or if it's going to be less than num. If it's greater than 1 and less than 1 and is prime is true. If all these 3 conditions satisfy, then you do it. So I remove the if condition here. So I take all the 3 conditions in the list comprehension filter and then I append this here. Now if I run it and there's no if. Okay, it's returning blank. So what I should do for I in the input, if is prime of I and or, there is no or and. So we are replacing the whole condition the opposite way. So instead of less than or equal to and greater than or equal to, we put greater than and less than. And instead of or, we put and. So this condition works. So when you see the first version of it, we do all the looping part in one stretch. So we need to have another flag to check if there is any divisor, and then you have to do the break. So to reduce that, we create a function within the function and we return false if there is any failure. And then we moved all this code to a list comprehension, and even this if condition We embedded that to the end. So all this makes this code like 5 lines of code, right? So you just go through the first and then try to reduce the lines and make it simple. Hope you like this video and thanks for watching.